Add and subtract them. Now that you know what the heck they are, right? What does it look like when I add and subtract polynomials? So let's add polynomials. Okay? Before we can officially add a polynomial, we need to review something from last year, something from pre-algebra, combining like terms. Okay? So I know, no matter who you had last year, you were taught to combine like terms. You were taught that 5a plus 7a was 12a, and you could add those coefficients because they both had an a, right? Okay? You were even taught that 5a minus 7b, you couldn't add, right? Because one had an a and one had a b. So what is 5a minus 7b? It's 5a minus 7b. It's nothing else. So maybe you even rewrote it. Maybe you said can't add because it's on like terms, okay? And then I feel like in 7th grade there's a very loose definition of like terms. I've heard teachers say, oh, like terms have the same variable. And if they have the same variable, you can add them. And that's partly right. So if I throw 5a to the third plus 10a at ya, they have the same variable. Can I make that 15 though? Can I do anything with these coefficients? So I don't know if you saw problems like this last year, but just them both having a's is not enough. They have to be identical. So they have to have the same variable part. And because if I were to write 15, what would they be? Would they be 15, do I have 15a to the thirds? No. Or do I have 15 a's? It's like you wouldn't know what exponent to write, and if that's the case, then you can't add them. So it's like I have 5 of these and 10 of these, and I can't just combine them to make 15 of like some hybrid, right? It's like trying to add 5 apples and 12 bananas. You don't have 17 apple-nanas, right? You can't do that. So just like this is the same as trying to add a's and b's together. You can't. So let's move on and see what this looks like. That's huge to keep in mind. So I'm going to take this polynomial, 2x to the third minus 5x to the second plus x, and I'm asking you to add this trinomial to it. 2x to the second plus x to the third minus 1. So when you see a problem like this, from now on, it's going to put them both in parentheses because they're basically saying take this trinomial and add it to this trinomial. And what's kind of cool is we did this kind of in elimination, didn't we? Right? In elimination, we didn't see them like in line with each other horizontally. We saw them stacked on top of each other vertically. So the good news is you could just kind of do like a little elimination if you want and just kind of say, well, I'm going to stack my x cubed terms here. This is going to be the column for my x squareds. You got to be really careful though, because if I'm doing it vertically like this, watch what I have to do when I get here. This is 2x to the third, 5x squared. Where does this one have to go? Underneath it, underneath the x squareds, okay? Because that isn't 2x squared. Where does this one need to go? Under here, okay? Now where does this one go? Does it go under this one? No, because this column is reserved for the x's, so it's got to go right here. Which means I kind of have an open space here, because only this polynomial had an x term, and an open space here, because only this polynomial had this. And then you can add. And if that is a pain in the butt to you, rewriting it, then don't solve it vertically. I'm going to show you an easy way to solve it horizontally. Yeah?
If it's easier for you, could you put like 0x?
Yes, if you really wanted to, you could just put a 0 and a 0x. Absolutely. Okay? And now once it's all set up, have at it. The only difference is nothing's going to, well, something might cancel, right? But 2x cubed plus 1 more x cubed gives me 3x cubes. These combine to give me a negative 3x squared. This just gives me an x, and this gives me negative 1. That's option 1, solving it vertically. Go for it if that's what you want. When you see me add polynomials, you will not see me take the extra time to set them up. Here's what I do. I just kind of look at it. I look and I pair them up. And I say, okay, I'm really put my fingers on these, and I do it in my head. And I say, if I have 2x cubed and 1 more x cubed, I'm going to have 3x cubes. All right? But watch, this is really important. This is an IFO, isn't it? So I'm done looking at that one, and I'm done looking at that one. And now, and by the way, did you also notice which one I put first? I want all your answers in standard form. So my eyes went to the cubes first. Now I'm going to look for any squareds. And there are 2 of them. A -5 and a +2 gives me that. I'm done with those. And then I look for my single ones, which is just this. And then I look for that. Okay? Do you want to know why I want you to put this answer in standard form? Can you think of all the ways you could write that answer? Holy cow. Like, if that's what my answer key is going to say, what if you said, oh, I'm going to put the x terms first, then I'll put the squareds, then I'm going to put that 1, and then I'm going to put those. Like, these are what your answers are going to look like. That's going to take me an hour to grade each test if I have to match them all up. So standard form is the way to go, okay? So guess what adding polynomials is? It's a heightened version of combining like terms with x. It's really easy, okay? So I know, did they coordinate with you, color coordinate last year? Did somebody say, I know when I teach combining like terms for the first time, I say, all the x cubes get one color. And then all the x squareds get another color, right? Have you seen this before? And then this is the only x term, and then this one is the only constant. And so how many colors do you see? 4. So how many terms should be in your answer? 4. Unless, when would it maybe not have 4 terms in your answer? Yes. If instead of instead of this, what if I had a +5x squared here? Okay, they would cancel. So set it up if you want this way, but you do not have to. All right, I want you to try this one on your own now. Ready? Go for it. Try this. You're going to take a -2x squared plus 3x minus x to the third, and I'd like you to add this trinomial to it. 3x squared plus x to the third minus 12. Use whatever method you want. Line it up. Just look at it, cross it off, highlight, whatever you want. So if you are not all about showing a ton of work, I would just go right to it and just put an answer. You will see me solve these horizontally. Okay, I'm not lining them up. I'm just looking at it. I'm looking to see that the highest exponent I see in both is a third, and I see that those cancel. So, because a -x to the third and a +x to the third cancel, will I have any x to the thirds anywhere in my answer? No. Moving on to the squareds now. I have 3 here and 2 negatives here, which is going to give me just 1. And now I'm done with my squared terms. Do I see any that just have an x? Yeah. Do I see any over here to combine with it? No. This is basically combining like terms, and that's your answer. Man, that looks crazy. That's your answer. It's not just 7 or 12 or anymore. It's that whole thing. Okay? Moving on to subtraction. It's so easy though. Like seriously, adding and subtracting polynomials is simple. When you get into multiplying them, there's a little bit more to it. But let's stick and ride the easy wave today. So let's do subtract polynomials next. All right, this is kind of cool because if you remember when we had to line something up in elimination, like let's say you had 3x minus 5y equaled 12, and then you had 8x minus 5y equals 10, you already did them. You already did some subtraction of polynomials. You saw that these were almost ready to cancel, but you had to do this first, didn't you? Do you guys remember doing that? And so what does that mean? It means you had to subtract this equation, that was called an equation at the time, from this equation. And what did this do? Distributing a negative just changes the sign of everything in there. So this 8x was positive, but then it became negative. This 5y, you two listen please, was negative, and now it became positive, and this 10 became negative. And then you did what you needed to do. Okay, the ones I'm giving you today are not going to have equal signs because that's equations, but I do want you to take this. I'm going to ask you to take this binomial and subtract this trinomial from it. So you're going to take a negative 2n squared plus 2n plus 4. Nope, sorry, make that a minus 4. I had it. Okay. So first of all, listen to what I'm saying. Subtraction, the order matters. So if I'm saying I'm taking this trinomial away from this trinomial, it's in the second spot. Okay? So this trinomial is being subtracted from that. Now, there's a very particular way I want you to do this, and be careful. I know what a lot of kids do. They try to save time, they try to whip through it, and they try to save as much work as they can, and they go like this. They go, because they know that all this negative sign does is changes the sign of everything. And then it becomes a mess, and then you're like, oh God, is that positive or negative? Some fancy pants even try to do it without seeing, because I can't go and start adding this to this right now. Because guess what? 4n squared is not going to be added with a negative 2n squared. Because then negative 2n squared is going to become a positive. Because this negative times this negative. So don't try to do this in your head. I want you to take this problem like this, and when there's a minus in the middle, here's what you're going to do. That was a plus. You're going to say, oh, so you mean I'm not changing anything in the first parentheses? No. I'm done with the parentheses now. I'm going to change this negative 2n squared to a positive. I'm going to change this positive to a negative, and I'm going to change this negative to a positive. And now I can add. It's like one big long expression with no parentheses and nothing to distribute. So going through and doing what I did up here does not work for everybody. Some kids need to see, oh, so that 4 really isn't a negative? No, because you're subtracting. And when you subtract, you have to subtract all 3 terms inside that expression. And once it's here, you're good to go. I want to do it in standard form. My highest exponent is here. So I have 6n squareds. So I'm done with those. And I have 1n term, and I'm done with that. And now I have a positive 5 and a positive 4, and I am done. Got it? So, making sure that this little sign in the middle is a deal breaker, isn't it? If it's a plus, go. Plus means go. Green means go. If there's a minus in between, you got to distribute the negative, then you're good to go. And that is essentially what you're going to have to deal with when you're given these practice sheets. So as you look at this, it might not be a bad idea to say, okay, I'm going to highlight all the ones that are addition, because I can do those and have an answer and be done. All the ones that are subtraction, though, I better slow up a little bit, because I can't just look and then combine. I have to distribute first. And please notice what I said. You're going to rewrite all of your subtraction problems. Don't just change the signs in the second expression and go boom, 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 because you're going to get confused. So now I would like you to try this subtraction problem, and then that is all there is to adding and subtracting polynomials. 4x to the second minus 3x plus 5. That's your first trinomial, and I want you to subtract this trinomial from it. Okay? Are looking to skip a little bit of steps, I will at least let you just do this. Change these. So this is the opposite of that. The opposite of a negative x is a positive x. And subtracting, there's two ways to look at it. Subtracting a negative 8 is the same as adding 8. Could you, do you have to recopy these three down here? No, not if you don't want to. Could you look at them just on different levels and say, I'm going to add these, and that? Yeah, fine. Okay, for me, it's just, I don't know, it takes me all of about 2 seconds, and it seems more complete with me just kind of having it all on the same line now. 2 different kids, you do it how you want. So this is going to combine positive 4 and a negative 3 gives me 1 positive x squared. These are going to give you what? Negative 3 positive 1. And then these are going to give you 13. And that trinomial is your answer. Thumbs up. Easy to do. Well, that's funny.